Hi everybody, in this video I will dive into Linux Logical Volume Management, or LVM for short. I'm currently studying for my first Red Hat certification and I could not quite get my head around LVM. I watched some videos, I read a lot of material and I ended up drawing a diagram that clarifies the terminology on a level that helps me to study further. Hopefully it can be helpful for you too. I will only try to explain the basic terms and concepts. It's not a how-to, it's not hands-on or deep dive. In another video I might dive a bit deeper into the subject, but for now I stick to the basics. Please comment if you think something can be improved. Well, all storage solutions start with a physical device, something you can buy in the store. We call that storage volume, or a physical disk, or block device is also a term you see related to this device. Storage volume always has a unique identifier, device name if you like, and you would see something like dev SDA as its identifier. And if you have another one, you could also see a SDB or an SDC. Anyway, let's say that we have one. So after you've purchased your storage volume, installed it, then you would create a physical partition. There you go. Physical partition. Some would call that a device, and as its identifier you would see something like this. Oh, dev SDA 1 or 2, because one storage volume can hold multiple physical partitions. You can like split it into multiple partitions depending on what you want to achieve. For now we assume you have dev SDA1, just one, and once you have your physical partition in place, you can create a physical volume so, and one physical partition means one physical volume. There's a one-to-one relation there. But if you have partitioned your storage volume into multiple physical partitions, you can create multiple physical volumes. Okay, this is not totally the truth, because nowadays with the rise of cloud solutions, you see that it's more and more common to dedicate your full storage volume directly to your physical volume. So you would not go the route by creating a physical partition or partitions and then creating physical volumes. No, directly from your volume you would create a physical volume. Of course you would then lose the option to create multiple partitions on your storage volume, so you cannot split it anymore. You would dedicate the full 100% to your physical volume, but if that's what you want, you gain some simplicity. So there's a one-to-one relationship here. So one storage volume means one physical volume if you go this route. After that, you would add the physical volume to what we call a volume group. And if you don't have a volume group yet, you would first create a volume group, or VG for short. And a physical volume can also be called a PV. And I say add because a volume group typically is made up of multiple, or one can also be physical volumes. So that looks something like this. One or more physical volumes create a volume group. So Your volume group is like the big resource you use to create your logical volume, because that's the next layer, logical volumes. Or LV. So one volume group can be used to create multiple logical volumes. So here you go. One volume group, multiple logical volumes. So once you have your logical volumes in place, you cannot use them directly. You need to create a file system. So I will, where will I put it? I will put it here, file system. And there you go. There's a one-to-one relationship. One logical volume means one file system. And this file system can be mounted like data, like so. What I want to add to this diagram is this line right here, because another option would be to totally skip the physical volume, volume groups and logical volume stuff and directly create a file system from your physical partition. And that basically entails not using logical volume management. But it's still an option. You see it a lot. There's a lot of documentation, and it can be confusing if you're not aware of this. So I will just add this to the picture. But of course, if you do this, you're not working with logical volume management, but I just add it to the picture so you're aware of that. For now, will I delete it or not? Might be confusing. I will just delete it, but just to make you aware. So this, you could go this route, but for now we won't. You could wonder, of course, well, let's say you go this route. What's wrong with it? Why wouldn't I do this? Well, logical volume management has some advantages over old school volume management. It's way more flexible when you think about resizing, and you can like make one big volume out of several smaller storage volumes, and it allows for real-time snapshots. It's a way to create backups while the system is running, so you have minimum impact while creating backups. But let me just delete this line for now. So here you have it. All the terms used in logical volume management, arranged in a, for me at least, a logical way. And what I want to do is now to show another picture. This one. I just found it somewhere else. It's a more concrete picture, an example more or less of how logical volume management would be more or less concrete. So here you see there are like two physical drives, SDB and SDC. Both drives have two partitions, SDB 1 and 2, and SDC 1 and 2, and they are used to create physical volumes. So you have like 4 physical volumes in this picture, and they're used to create one big volume group. So 4 partitions, 4 physical volumes, 2 physical drives are used to create one volume group. And this volume group is then used to create two logical volumes, a home volume and a data volume. And then these logical volumes, they are used to create two file systems, a home file system, which is formatted as ext3, and a data file system, which is formatted as xfs. And if you compare it, let's see, if you compare it to the picture I just drew, you can see indeed that it's a valid option to arrange your logical volumes, and I hope this makes it a bit more clear, adding this concrete picture. Well, I think this is all there is to it, and this is all I can tell you about it without going into more details. Hopefully it helps you to gain more understanding of logical volume management. Good luck with your studying, and thank you for watching.